Okay, so what I was about to do today, yeah, is we yesterday, just a refresher. We studied yesterday static block, right? Static methods and non-static methods. Whether static methods can access the non-static data or variables. Answer is no, right? Abstract class and interface. Abstract class is a class which has concrete methods, also abstract methods. Whereas interface will only have abstract methods, no body. All the methods will have no body, only the semicolon. Then we will do this. I marked it as pending. How do I sort a list of strings? Then we studied yesterday string buffer and string builder. Buffer is synchronized and builder is not. So buffer is synchronized, that is why it is slow. Builder is non-synchronized, so it is faster. Then we did a small program to see the time taken by builder and buffer, right? So we found that buffer is taking more time than builder, double the time. Then we had something in the past also. Yeah, there are two things which are pending. I think one was the switch case and the difference between equal to, double equal to, and dot equals. So let's go ahead. Think yesterday I fixed that issue. Switch case, switch case. Yeah, so it was a very simple. There was no error actually. I just copy pasted the same piece of code which we had. It was here. It was like not working, right? So the same I pasted here, and where is the switch case? Yeah. So what was the question is, if you see string in the switch case or not, right? So that was the intent of that topic. So like this, if can we pass any string inside switch case? So the answer is yes, we can pass, right? So question was, can we pass a string in switch case? And that is yes, we can pass. So now suppose if I have 3 here, what will happen? It will compare with the first case, 1 is equal to 3, no. Matching, it will search the matching. 2, no. 3, yes. So this 3 and this 3 matching. So it will print this last, right? So let's run it. So switch case we already know is a Java construct, right? To validate multiple like conditions in one construct itself. So based on whatever you want to validate, you will pass in switch, and you can have multiple cases inside switch. One of the case will match with the value you have passed, and that section will get executed, right? So if I run this, 3 should get executed. 3. See, 3 got executed. So this condition 3 and 3 matched. So 3 got executed. So let me change this 3 to some other string, Bangalore. And I will change Bangalore to here now. Bangalore. Right, the remaining I will keep as Hyderabad. And here I will do Mysuru. Okay. Let's run this. Which will work now? According to which one will work? This should work, right? Bangalore here and Bangalore here matching. So now the second 2 should get printed. So 2 got printed. So switch is a conditional statement where based on the parameter you have passed inside the switch brackets, one of the cases will get executed. So which one? The matching strings, right? So there can be one more option, like instead of strings, we were working on strings, so I was showing you whether we can use strings or not. But there can be integers also, right? So we can just do this also. So now which one? switch 1 is there, so 1 will print. Integers are allowed, but we were asking whether strings will allow or not. So right, integers 1 is matching, 1 is equal to 1. So this got executed. So I said 1000 here, 100 here, and I put 100 here. Now if I run, which one is matching? The third one. So 3 will get printed, right? So switch will just expect the value here. This value is searched in one of the case conditions, one of the case blocks, 1 block, 2 block, 3 block, and we can have numerous blocks. So these blocks we can repeat for thousands of time, any number of time, but it should be unique. So this was 100, this can be 4, right? It should be, this should be 6, this can be 8, right? So we can repeat this any number of time we want, right? And this is main, this is the closing of the class, right? So this is what is switch statement, which that day it was showing an error. So I just copy pasted that program here. It was working. Maybe in that class some other error was there. Okay, so next one, you understood, right? Switch, very simple. Switch and multiple cases. So whatever switch you are passing, value you are passing inside the switch, right? So that will be compared with all the cases, and then that case which where the value matches will get executed. So 100 is matching with this case 100, right? So it will execute this. So if there is no match at all, then there is a default section also. So there will be a default. Say for example, SYS. So this will be your default, you can say. Hello. Or default, DEFAULT, right? So it will be default, DEFAULT, default case. Okay. Default super expected. On def token, default super expected. What do you mean by that? What do you mean by that? Okay. So now what will happen? Suppose I am passing something which there is nothing in there, say 20,000. So 2,000, right? So there is no 2,000 here. So all the cases will be compared. First will compare first case, second case, third case, fourth case, fifth case, eighth case, whatever. And then if it is nothing is there, then default. So let's run this. So default will execute, right? So this is the default switch with so many cases and default. So default will be evaluated only when there is no matching case, right? So this is what is about switch statement. So this is also important use. Now another one is equal to and dot equals, right? So I wanted to show you how they don't work. Now see here, string comparison, address comparison, right? So we all know in Java, equal to, right? We'll put a comment, equal to operator is used to compare address of the strings, and dot equals is used to compare the value of the strings, values of the strings. This was this discussion we had done. But that day when I executed equal to S1 hello, S2 hello, and if I want to compare S1 equal to S2, it was showing true and it is correct, right? So we were expecting that no, since the addresses can be different, value may be same, but the addresses can be different. But what is happening is, when we know the concept of this, right? Constant pool and heap memory. So this whole big circle is heap, Java heap, right? So just put a label. This is heap. Everything Java stores inside is heap, but inside that heap memory, one portion is called Java string pool, string constant pool, or Java string pool, constant pool. So, or called literal, string literal pool. There are two names, right? So what it will do, both string 1 and string 2 have the same value, so they will also contain the same address. So 1 2 3 4 5 6 7, this is the address, because it is see, this is going, Apple is residing in Bangalore, so obviously str1 also will have address Bangalore, str2 also will have the address Bangalore. 7, right? Both are, because Apple is in Bangalore. So say this string constant pool is Bangalore, this whole is Karnataka, right? Heap is Karnataka. Then what will string 1 contain? Bangalore. String 2 also will contain Bangalore. So that is why equal to operator will say true. But now these two are done, right? They have the same address. Now string 3, if I create another string S3 with a new operator using new string hello, value is hello only. So what will JVM do? JVM will not go and search whether hello is there, right? So I'll change it to hello. This I will erase. So it is hello. We will use hello only so that we don't get confused, right? HELLO. Now hello is pointed by str1, str2, right? So both have the same address. But now when we create using a new operator, though the value is same, JVM will not go and search whether hello is there in the string constant pool. It will go and create a new memory. For that, it will create a new variable, completely new. So it will create hello here also. Though it is there in memory already, it will not use that. So what it will do, create another variable hello, and then it will pointed by the next variable s3, right? So this will be pointed by s3, right? So this is s1, this is s2. Don't get confused. S1, this is S2, right? So S1 pointing to hello, S2 pointing to hello have the same address. But when I create another string, value is hello only, but using the new, you are forcing the compiler, JVM, okay, create me a new one. Don't use the existing one. Create a new one. So it obviously will create a new one and it will point it by a, so address will be something else, some address, right? It will have some address. Now when I compare S1 with S3, it will say false. S2 with S3, false. They don't have the same address with double equal to it. Okay. But if I say dot equals, then dot equals means S1 dot equals S2, obviously same value. S1 dot equals S3, same value, right? So it will pass. So let's see. See now first what I am comparing S1 with S2. So S1 with S2, hello and hello. So obviously addresses are same. It should throw true. And S1 with S3, it should show false. Why? Because they have different addresses. And then equals will always be true. Why? Because it compares the content, it compares the value. So both our value is same. So S1 equals S2 is also true. S1 equals S3 is also true. So let's run it. So the sequence would be true, false should get printed, right? See, true, false, true. Yeah, true, false, true. So true, false, true got printed. Got it? So don't get confused. So that day I was expecting S1 equal to S2 should throw false in whatever conditions. But if the value is same, then JVM assigns the same address to both S1 and S2. So that is why equal to will say true if you compare S1 and S2. But if you create with a new operator, right, then you obviously you are forcing the JVM to create a new variable inside the string constant pool. So this string constant pool is used by Java for string literals only for string, because strings are very critical. They are, what is that? There is one word, right? Immutable. So to make strings work, since strings are immutable, they have assigned a separate memory location so that no one can interfere, right? Other things you can store somewhere else, but let's store string in a string constant pool separately, so that the Java can compare. If I allow Java to use the whole heap memory for storing strings, so it has to search a big memory location, big area of memory to find out hello. But if I am allocating a very limited area in memory only for strings, so it will go and search in this small section only. Okay, hello is here. He will quickly find it. But if I say, okay, there is no string constant, only one memory is there, then what will happen? It has to search in a big area of memory and search for hello. Because Java will, if you are creating any string variable, it will go and search in the memory first. So if it is already that value is there, it will just give a new, give the same address to that new variable, right? But since the area of memory can be very big, it might take time. So what they have smartly done, they have created a string constant pool separately inside, allocated for strings. So allocation has been done in specific area of memory. Okay, let's use certain area of memory only for strings. So the compiler, the processor will only scan that area and find out this hello quickly. Otherwise, it will take time for to scan the big memory area, right? So that's why this concept has been created in Java string constant pool or literal string literal pool. Okay, it is also called string literal pool. Special memory location to reuse the string objects, right? To reuse whatever is there. Hello is there. So any another variable s4 also if I create using equal to string s4 equal to hello. So what it will do? It will not go and create another memory location. It will say, oh, I have already a hello. So I will point. So I will just point it here, and then it will be, that address will be assigned to S4, right? Same memory will be assigned to S4 also, right? So it is for efficiency purpose of strings, because strings are the most widely used variables in any Java program, right? Now, because human interaction is done using strings, right? We use words, sentences, and all sentences are a group of words. That is why they have given special preference to string class. And string class has a special feature called string constant pool in the heap. Right? So the confusion is clear now. So whenever you are forcing with new operator, then in that case only a new variable is created. New memory is allocated, and that memory allocation, memory address is assigned to that variable. That is why when you compare S1 with S3, it will say false. Right? Because the addresses are different. But when we say S1 equal dot equals S3, still it will be true. Why? Because it compares the content. So HELLO, right? So it is passing. So this is a core concept. Don't get confused. Heap memory and string constant pool. String constant pool specifically allocated only for strings for reusability, for managing how the strings will get stored. So any duplicacy, it will not allow. So if hello is already there, just assign that address to the same new variable, right? Keep assigning how many thousands of S1, S2, S3 till 1000 also if it comes, they will all will contain the same address. So that is why it will always be true, right? But dot equals will contain the compare the value or the content of the variable. That is why they will pass, right? Always. But if it has some other string, say HELLOW, then obviously equals also will fail, right? Say for example, I have string S5 equal to L, right? I created a new one, and string S6 equal to cell, right? So I have this true. Now bell will be created inside here somewhere, right? And S also, it has an address, and S also, SELL also, right? So these two will be, addresses are different. Bell is created in a string constant pool, cell is also created, so they will have different addresses. But now the values are also different. So now if I say compare S5 with X6, S5 with S6. Now even equals will say false, right? Why? Because we are, say, run in debug mode. It will stop here, stopped. So it will say false. Why? Because the values are different. Got it? So this is how the double equals and dot equals work. Okay. So those two were pending, I think. Now we have cleared them. So I will remove this ending from here. So any confusion, any questions you have, raise your hand, let me know. But very simple concept. Double equal to. Okay, so now let's go back to our, yeah. So yesterday we had this thing also, sorting a list of strings using, there are two ways I will show you now. So how do I sort? Say let's create a new class, strings sort. Okay. Control D will remove the line. So say for example I have this line. These are all shortcuts you should use. I want to delete. Control D. Control key plus D key. Keep deleting. All your things get deleted. Right? This also if you do Control D, it will delete. Anything you want to delete, it will delete. Control D. Okay. So let's now compare this. How do I compare strings? Sort the strings. Sorry. So let's say we have a string array x equal to say hello. Just now we created hello. Then we will put hello, right? What happened? Yeah. Okay. So then we will have Zello, then Zello, then below, right? So say for all these are the samples of strings I'm taking Tello. Okay, so I want to sort alphabetically. So which should come first? B should come first, right? B is the first letter in, then B should come, then F should come, then H, then T, X, and Z, right? So this should be alphabetical sorting. So what we will do? There is a method collections dot sort. Collections I will come, but collections dot sort, right? So if I use this and pass this X, right, and print. Yes, oh, just whatever you want to test, use inside the string class, SYSO. So what it is saying, the method sort in the type collection is not applicable for argument of string array. So what we will do, we will have to list. So it is asking a list. list of strings. So let's create a list of strings. Okay, so list of, how do we create a list of strings? Like this, list of strings, right? We have to import, remember that always, import equal to, now the format of string will be, list will be different, right? So you cannot assign like this. So we have to create first a new array list and of string, right? And import this array list also. Now what we have to do, x dot add, right? So let's say hello x dot add, hello x dot add Zello x dot add hello x dot add hello. Okay, so let's take this. So the order will be B first, F first, H then followed by T and followed by Z. Okay, so now print also collections dot sort. So now this is sorting. So collections is a class which has a Java util dot collection. The class consists exclusively of static methods that operate on or return collections. It may polymorphic algorithms that appear on collections wrappers, which return a new collection backed by a special collection. So collections, I'm coming in after this program, but I mean, so there is a direct mechanism, right? So we can either use some traditional approach to do the sorting, right? Or we can use direct methods. So traditional, generally, if you start using, you have to start writing, count the length of the list, array list, right? And then to use a for loop or a while loop, and then iterate over that. And then finally, you have to do character by character, right? First character, second character. So there would be a long process in traditional approach. So Java is itself doing it for us now, and then it has provided a sort method. But now this sort method returns what? It returns nothing. So what it does, it sorts and stores the value inside X itself. So SYSO, just print X. Okay, so let's run it. So what it did, it sorted. B is coming first because B is the earliest one. B, F, H, T, and Z. Right? So this is how we can do sorting using collections.sort. Very simple, right? Then dot, sorry, the other one is list, right? X is a list, X dot also will have a sort mechanism. See, list also has a sort. What it expects? It expects a comparator. The method sort comparator, then in the type list string is not applicable for argument without anything. So what it does, it 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 expects a comparator inside this. So that is a longer approach, but it also has a list class, also has list interface is also has a, see, list is an ordered collection, right? The use of this interface has precise control over whether the list each element is inserted. The user can access elements by their integer. So now by their index, right? Using index, we can access the list values. So there are so many methods inside list, right? So we have other collections also. So all the information, see, you can take help from here also. What methods? Provides 4 methods for positional access to the list. Lists are zero based. Index starts from 0. Note that these operations may execute in time proportional to the index value of some implementations. Thus, iterating over the element in a list is typically preferable to indexing through it, right? Linked list if the caller does not know the implementation. Okay, so now there is a default method available inside this X also, because X is a array list. So array list also has a default method of sort. So X dot sort, but it is asking add argument. So if I use that suggestion, that it adds a null. But what it is expecting, the method sort comparator, and then you have to provide the superstring in the type list. String is not applicable for the argument. A quick fix is available, but is this needs a comparable. So so generally in automation, this requires UIRS. This requires advanced Java concepts, right? So where comparator we have to use. Comparator is required. So we will, when we work on, start learning comparator, because that's also a interesting topic, comparator. Then we will show how this will work, right? X dot sort. Directly it is not working, but collections dot sort is the straightforward way of sorting it, right? It is directly saying. And then there is another way, I think. One more is there. Array list, arrays dot sort, or arrays is there. Let's try that. Arrays dot sort. I think arrays also, when we will pass X, again it is expecting the method arrays is taking arrays. Okay. So now if it was an array, right, string array, like for example, this was a list. Right now I am creating a string array, like I started with, right? String y equal to, and then inside this I have, say, a b c, then zac, right? Say for this I have tac, then fac, then yac, right? So this, if I have this and I want to do sorting, right? So arrays also has a method called arrays.sort. So there are two ways, right? So this I will teach when we learn on comparator. This is also interesting. But now for array list, collections.sort. For arrays, arrays.sort, right? And print it. We can directly print y, right? So this I will comment for some time. Okay. So let's run and see what it does. See, it gives a object. The first one worked, but since this is returning, this returns the same array, right? Sort the specified list into ascending order and stores in the same, and so we can print it. But this sort does not return the same. So what is the return type? It is returning void, right? So it should return string. Then only SYSO will print. So we have to now see how we have to print this. How do we print now? Tell me. Was an array with so many strings, right? We sorted it using arrays.sort. But then I want to print that array now. How do I print it? You can just write a loop for int I equal to 0, I is less than y dot length, I plus plus, then print it, right? Y of I, right? So now what will do? It will print because we have used a loop, for loop. For loop is a conditional loop, right? Like while loop, we have for loops, we have switch cases, we have if conditions, and then do while loops, right? So all these are loop conditions in Java. So what I did first, I used collections for array list. Then I used an arrays dot sort for arrays, and I'm now printing one by one. So after that, if I run this, see now it is sorted and printed. A is coming first, F second, T is third, Y second last, and Z is the last, right? So this what it will do? It will do sorting, right? It will sort the elements and store in Y. But since we are printing one by one in println, see there is another method called print, right? So what it will do? It will not print to the next line. So you have to keep experimenting, right? So now let's run this. What will happen? You just see. See, without the next line, it is printing in the same line, but no spaces. So what we have to do? Just add one comma here. We want to segregate them. Print. So first value it will print and append comma. So again on that it will keep adding to it. So now let's, if I run this, it will come with comma. ABC, FAC, TAC, YAC, ZAC, but last also comma is coming because this is what we have asked them to do, right? So println and print. There are two methods to print on the console. One is println, go and print on the new line, and print will just print on the same line, right? So this also sometimes some people might ask you, is there any other method apart from print ln? So you have to say, yeah, print is there. Basic print start is on the same line. Print ln on the next line, right? So we
Hello.
saw, yeah.
Yeah, instead of using for loop, we can go through toasting method, right? Array start toasting.
Toasting.
Yeah.
Can you tell me the syntax?
System.out.println.
Okay, that's what.
Uh, yeah. Of arrays dot toasting of y.
That is the
Arrays dot toasting.
two string you are saying. Okay, two
Yeah, yeah.
string
Of
of
y.
y. Y.
Yeah, yeah.
Yes, yeah, that would might also do it. Two string. You are converting that array to a string. See, now it is
String.
doing it. Yeah. So this is a very good way of also doing it because array obviously is in array format, right? Now if I convert that to a string and you can system dot out println always takes strings, right? So we have converted that to a string and then we have printed it. Yeah. So this is the traditional approach and this is the, there are two
Simple.
simple, yeah, efficiently we can print it. Thank you. Thank you so
Okay.
much. Okay, I think we are good with sorting also now. We saw how we have to sort array list using collections dot sort. How do we sort arrays? Arrays dot sort, and then print it using by converting to string or for loop, right? So for loop is a traditional approach where you can just loop iterate over all the elements one by one using the length method till the last element, go till last element and keep printing it, right? So this is another way of doing it. But since if you do this, what is happening is it prints on the same line. If I use, then it prints some characters at the end also because I'm asking to append. So you have to do some string manipulations to remove this last comma to other. See this one what she has suggested is also giving us in a array format directly, right? The same format like we have for collection dot sort. This also is we are getting in the same format, right? So that is the better approach. But this also sometimes if it is a very what intensive data intensive array where you have to manipulate manually, right? Some specific element you have to catch in the array, then these loops are used, right? After sorting, you want to do some operations, then for loops are also required to go to that specific element. Say if I have to print, say out of say 1,000 elements are there in the array, and I want to print the 655th element, and I want to manipulate that. So what you have to do, keep a loop. Then if the I value is 655, then do something and then print the array. In that scenario, we have to use the for loop. Otherwise, if you just want to use the sorted array, you can directly use this arrays.toString of y. Just pass the array, it will print it, right? So it is already sorted, right? Dot. So there is a reverse order also, that also I will tell you. One pending would be reverse order. Reverse order. That also I'll tell you. Okay. So it will be, this will be reverse order. I will tell you. And then comparator, using comparator. These two things will be pending. Okay. Now we have already finished string buffer and string builder. We saw how the efficiency or speed of these two classes are. So string builder is efficient and faster, whereas buffer is thread safe. To implement that thread safety, that is why it takes more time, right? Thread safety is what? Thread safety means at one point of time, no two objects can access, right? Only one thread can access. What is thread? Thread is what is thread? In Java, there is a concept called threads. Very, I mean to say, any programming language, right? Or any computer. Without threading, nothing will work. Threading is when you see memory is limited and you have processor, CPU, right? So CPU has to go and read things from memory continuously, right? Give user is asking something to print or access some arrays, right? Array list or vector or stack or queue, whatever. So keeps processor is almost all the time busy reading the memory. Now, what will happen is when processor is going and reading the memory, so there should be some efficiency we need, right? We cannot say, okay, one object is saying go and bring that array, and another object also going asking to bring that array. So what will happen? That the first object might go and take that array and manipulate that array, right? The second object will get confused. Oh, I had this balance, account balance in 1,000 rupees. What happened? It is zero now. What? So he is also trying to withdraw, right? So first object has already got access of that account and withdrawn money, and the second object is expecting 1,000 to be there. He's also expecting to withdraw. So to implement this type of things, to first the safety purpose, they have said at any given point of time, object 1 will operate on the account. It is a thread. This thread will block that memory location or CPU time. CPU time plus memory, both, right? So it has to block. Now let this finish first. The first object will work on the request the processor. Processor is also blocked. Now processor is going in to read the memory from the memory, right? The value from the memory, account balance or account, whatever account information the object is asking. So this first thread has to complete. Only once the thread is complete, then only the second object will be allowed to talk to processor. Processor will be free. So I am free now, tell me what you want. Then the second object is request is coming to processor. Processor will say, okay, give me the account details. So by that time, the first object has already accessed and completed the operations it wanted. So there will be no discrepancy. So now the second object knows that, okay, there was an operation done by object 1, already done recently. So now on the result, what happened after the first object did, that the second object will take on. Now you will know that the balance is not there. Now what he will do, he will say, okay, no problem. I'll use my own cash. I don't have account money in my account. So that's just an example I'm giving. So this is how the processor is blocked by a thread. I was talking about thread safety, right? So buff builder is not thread safety, buffer is. So thread safety means at one given point of time, only one thread is accessing the processor and the memory. Once that thread's task is complete, then only the second thread will be allowed to talk to processor. A processor time will be given. There are conditions we call like deadlock, right? There are conditions like deadlock where two threads requested the has gone to the processor and got approval from the processor. You both can access me or get my time. So processor is so fast. In our eyes we cannot see that, right? It is very, very fast. In nanoseconds it works and finishes things. So sometimes in rare conditions there can be deadlock also, where there is a conditions, right? What will happen? No, one infinite loop will, by because of user only, because of user's mistake only, an infinite loop will happen in the first thread operation. So the processor is not getting free at all, right? So processor is trying to complete the task, but there is some infinite loop happened because of some condition. Say I is for loop only, you can say for I equal to 0, I is greater than 0, I plus plus. So how many times this for loop will run? Infinite, right? You got to know what I am telling. For int I equal to 0, I greater than 0, I plus plus. So what will happen? Any number after 0 is greater than 0, right? And there is no limitation to the number of numbers. We can go till infinity. So the processor is processing and processing. 1 is greater than 0, 2 is greater than 0, 3 is greater than 0, 1000 is also greater than 0, 10,000 is also greater than 0, billion is greater than 0, trillion is also greater than 0, right? So there is no limitation in this loop. So this is called an infinite loop. So such infinite loops, sometimes some users will, by mistake, not intentionally, and some hackers will be there who will create such infinite loops so that the system crashes. So what will happen now in this scenario? Processor is busy fulfilling the request of the first user only, first thread, right? So it will go and execute this for loop and continue and continue and continue. So the first thread operation never gets complete. So it is stuck. So how it will give time to the second thread which is waiting, right? It will get deadlocked. So this is a deadlock condition where in some, by some manual error or human error, generally systems will not make error. Only because of some mistake done by user, then only these deadlock conditions or infinite loop conditions will happen, and then the system, the server is always busy or it hangs. See, sometimes our system hangs, right? So what happens, right? We have opened Word also. See, so many things I have opened in my laptop. So these all are coming from RAM, right? Not from hard disk. Whatever we are seeing in with our eyes, right, in our laptop screen, all are pulled from hard disk and stored in RAM. So these are all basic concepts I'm trying to give you so that you are aware how system works, how laptops, how processors are completing the task. So whatever we are seeing, see, everything resides in hard disk. Obviously, when we install, when we buy a new laptop, the memory, there are two memories. One is RAM and one is hard disk, right? So hard disk will install Windows operating system, and any software we will store in hard disk. But when I switch the button of the laptop, then what is that laptop doing? Laptop is bringing the basic things required. That's called booting, right? The booting process during the reboot or boot, it brings whatever is required for the user to use the laptop. It brings from hard disk and puts into the RAM. So RAM's 16 GB. If you see in your mobile's RAM or computers, laptops RAM, you see out of the 16 GB, 5 GB is almost blocked by the operating system only, right? So 5 GB of RAM is blocked by the operating system because it's a heavy application, right? Obviously, operating system is also a program, right? To display these folders and basic operations on the folders and all the views the user needs to work with the laptop. Everything is created and then put it in the RAM. So only the remaining 16 minus 5, 11 GB of memory is available for other purpose. So once it brings from hard disk to RAM, then you are ready to operate. So your operating system shows you the screen, shows you the home screen, all the folders, whatever you have. See, all the folders on your desktop. So you should not, you should always manage your desktop properly. If you keep everything on desktop, no, every time system is rebooting, you're starting or opening your laptop, everything has to be read from hard disk and brought into your RAM. So the lesser the value you have on your desktop, the efficient your laptop would be. So if you keep everything on your desktop, every time system is starting, it has to bring from hard disk and put it into RAM. So the RAM gets filled. So big folders if you create on your desktop with so much of data, then all your memories get filled initially and your system becomes slow. So don't create anything more on the desktop, right? Because desktop is a view, and desktop is a view which the operating system always has to give to user. So memory gets filled in, the RAM gets filled in. So what you have to do, you have to always go to your drives, right? So these drives, C and D, whatever data, store data there, right? So every time this one, the processor need not bring it to RAM, right? So that's the core. So hard disk and RAM. So they manage like this. So be careful. Use efficiently. Don't put everything on desktop. So that's what RAM and hard disk are differentiated. So everything initially works in resides in hard disk only. Everything is brought into RAM by the processor for the user, because obviously you have put everything on desktop. So you want to see it the next time, right? Oh, I had put everything in desktop. Where is that folder? So I need that to see. To show it to you, so it has to be brought to RAM. So whatever you are seeing on the screen, even these icons, all this date, Wi-Fi, this one controls, battery controls, everything is coming from RAM, right? So RAM is a random access memory and it's a volatile memory. So once you close the application, the memory gets erased. Once you switch the laptop, the RAM is cleaned up. RAM becomes free of everything, right? So RAM is a volatile memory, whereas hard disk is a non-volatile. It always has to store the memory data inside it for lifelong, right? Okay, so now let's go to collections framework. So java.util.package has all these classes and interfaces, right? The collection framework we all know. Maybe during our college days, if we have this computer science subject, we had this, right? Let's go through it. We will not go in detail of all the classes and interface, but from an automation job or interview point of view, we will try to understand and see how much we should be using them, right? So we'll go not in detail of what is iterable, what is collection, how it is implemented, how list it is, right? Extends the collection, then what actually is happening. But we will try to see how they are used. So our purpose is, see, Java has given a collection, right? Framework. So this collection of framework is just a segregation of different classes and interface. So for non-IT people, what is class? Class is a logical form or a template where you can have abstract methods, non-concrete methods, right? Abstract class. And then you have interfaces. Interface is where you don't have the body. You don't have the implementation of any of the methods, right? Yesterday we saw interface. Where is that interface? I think here, right? So all this, see, we don't have any methods, body, no implementation. So this will be implemented by the child class who extend this interface, right? Who implement these interfaces. So that's what here also in collection framework also they have provided us a set of interfaces. See, all these initial top ones are interfaces. Why the top ones are interfaces? Very simple. These are parents, right? All these are mostly parents. Yesterday I told you, if the parent only does the duty, then what will the children do? So what they will do, they will define. They are the controllers. So what the interfaces do, they will define the methods only, nobody. So they will say, children, my lower children, please implement on your own. I will tell you what methods you have to implement, but I will not implement. I will only give the name, the return type, and the parameters. Right? Then you can override the parameters also. You can do any implementation inside your method. Right? So when you talk of runtime polymorphism, so that time data by runtime binding will happen. So operator overloading, operator overriding, those things also will come into picture when the child implements. So this whole collection framework, initially if you see, all of them on the top are interfaces, the orange ones. The greens ones are classes. The greens ones at the lower level are classes because they are the child, right? They are children. So they only implement the actual things. See, array list, linked list, vector, stack. It comes under list, right? Queue has priority queue, but there is one more DQ interface, which is then the array DQ. There is a class which implements the DQ, and this also talks to DQ sometimes, occasionally. And there is a set interface. So set interface is implemented by hash set and linked hash set, right? So this will tell the methods to implement. This will implement them in, and then sorted set. Sorted set is another interface which implements set, and then there is a tree set. So tree set follows the tree mechanism, right? We have this tree mechanism in Java where, just like a tree in the natural environment, it has a foundation root, right? And then it has so many branches, and branches means how to, now there is a tree. Now there is an apple hanging on the left side, there is an apple hanging on the right side or on the top. So these all are variables. Now how do I traverse? I have to traverse from the root till the left branch and go to the apple and bring on the right side apple. Then similarly on the left side, if there is an apple, go and bring. So the user will say, give me the right hand apple. Then it will say, okay, right hand apple, there is an apple on the right hand, but which branch? So you will have to provide the branch name also, and then it will bring that apple. Using the information provided by the user, it will traverse. So traversing a tree is almost the same like you climb a tree. So that is why the name is used, tree, right? So it is all real life implementations. And arrays, we already have seen arrays. Array list already we have worked on. Today also we created an array list and sorted it, right? Linked list. Linked list is like, I mean to say, the first and the second and the third are linked. So first will be there, initial element. You add to the linked list. Second it will not just store its content, but it also store the address of the first. Third will not only store its content, it will also store the address of the second. So they are linked. So they are linked to each other, right? So there will be a doubly linked list used, where the middle part will be the content and left and right will use the address of the previous and the next, right? So that way linked list is implemented. Vector and stack are seldomly used in automation, but these are also a type of data structure. Queues is like first you stand in a queue, right? So first in, first out. So whoever starts in the front of the queue will get the service first, right? When you go to a restaurant, or when you go to a bank, or when you go to a railway ticket counter, or any queue, right? So the first one who is at near the counter will get the service first. Same real life scenario they have implemented as queues. So it will be priority given to the first person, first in, first out. So he will take the service and he will be out. Stack, here is the stack, right? Here is the stack, last in, first out. See, stack is putting on the top of each other. So when you stack plates, right, the first plate which went down, which started the stack, will not be able to do anything. Why? Because it is pressed by so many other plates. So the first plate or the last plate which came and joined the stack will be happy, will be the happiest person. Why? Because he is there to come out, right? He can easily come out. So stack is the opposite of queue, right? So queue is first in, first out, and stack is last in, first out. LIFO and FIFO. Set is another interface which we yesterday I told you a little bit about set, that it does not allow duplicates. Yeah, so all these lists and all allow duplicates. Queues will allow duplicates, right? Set, it does not allow duplicates. Set is that's why all these banking people, like credit card or Aadhaar number or wherever where there is security required to store uniquely, to store the data uniquely, there sets are used, right? Set will only identify. So set, how set works, right? Set uses different mechanisms. So there is hash set and linked hash set, and there is tree set, right? So all these three classes, they have their own mechanism of implementation. But as a set, as a parent set, it says, okay, implement these many methods. So child classes will implement them on their own way. So this is how the whole tree of the framework is iterable, followed by collection. Collection has three main interfaces: list, queue, and set. Then list will have its own three classes: array list, linked list, vector, and stack. Vector and stack are related. Queue has a priority queue and DQ. DQ also is an interface. So why they have made this as interface? Suddenly they could have just directly put queue, right? Why? Because later on, once they were implementing queue, they found certain things which is very common, right? But different from priority queue. So what they did, they said, okay, let's create one more interface and let the child classes implement them. So they introduced one more interface here. Similarly, set has direct two classes in extending the set, but one more interface so that the tree set can implement its own, because they are unique. Tree set methods are unique, very different from what hash set and linked hash set does. So these are separated by using an interface. So this is how the whole structure of our framework, collection framework follow, right? So now these dotted lines means implements. So the class implements the interface, and this hard or solid lines, it means extends. So this interface extends this interface, right? Similarly, the set extends collection, list extends collection, right? And collection extends iterable. So this is how all these are there. Now let's start with the list. List already we have seen, right? Just now. Simple. What is the type? String list one equal to new array list, right? So if I use this and I can create a list. So let's see how. I think I have already array list with iterator. Yeah. So now array list with iterator, array list test already we had done some time back, day before, I think, when we were working on this one, strings, right? See, array list we have created. We is using object also we can do. Object is a common type. Yeah. So remember, list of strings, list of integers will always store same type of data. But if you want to store multiple type of data, then what you have to do? You have to create objects. So object is an account, right? Say person. Person can have a name, address, age. So name is string, age is integer. So if you create a person object, a person class, and create an object of that person class, we can store all those objects in the array list, right? Using the add method, and remove by using the remove method, right? Remove method. So these all were already completed, but then I wanted to show you comparator today. Sorry, iterator. So I created an array list of strings A1, A2, A3, A4, right? We already have it. We have already seen it. Now we have added them to this array list called list. List.add A1, list.add A2, list.add A3, list.add A4. Now, how do I traverse it? Right? So traversing, Java has provided a class called iterator. Iterator, create an object of iterator, then pass this list, right? Whatever you have created, array list dot iterator. So now this iterator object is ready for us to iterate over the elements of the array list. So iterator is the same condition like while iterator has next. So first it will point to the first one, then it will print it. Then iterator dot next, it will go to the next. Then iterator dot next, because we have put a condition has next. So does it has a next value? Yes, A3, print A3. So let's run this. See A1, A2, A3, A4. So in collection framework, basic is array list, the most widely used out of that tree what I have shown, right? The framework whole data structures we have. So this data structure array list is the most widely used. Arrays, array list, sets, and hash map. This will be the most widely used. Strings obviously we have to use because every individual string also we want to work on, right? When we capture from Hyundai application, I told you that day, our Hyundai car application, right? All these are strings. See, all these are strings. Everything what human can read is a string, right? Even the numbers 1, 2, 3, 4, phone number, mobile number. See, if I go here, copyright 2023, this is also a string. We have to read them as a string first, and then do a parseint, integer dot parseint, and convert into integers, right? So that we will do during our automation. But whatever you see on any web application, right, most of them are strings. There can be other objects like tables, web tables, right? That also I'll tell you how do I read a web table. So there, like a small Excel table, like an Excel, it will be all rows and columns also displayed sometimes, right, on the UI. So many places. So those type of tables how do we read? So Selenium has the options to read the web tables also. But basic concept of any automation is to read the elements on the UI. So these all are elements. This person's image, this is a photo, right? So photo is also an element. These texts all are part of one element. Then these all are also some images, right? So this arrow is also one image, and this logo is an image. This is a text, right? Or links, hyperlinks, right? How do I read all the hyperlinks? All these are images, right? Or hyperlinks. So all these are in automation world they are called elements. So that is why we say driver dot find element or find elements if they are similar. See, these all are similar. So we will together driver dot find elements, and one XPath, common XPath will bring all this in one list of elements, right? So driver dot find elements we will be using when we do automation. Driver dot find element and driver dot find elements. Find element will give one element. Find elements will return a list of elements. So send a user's common XPath or property, whether it is class or name. Then it will search the whole DOM structure or HTML source page, and then it will say, oh, I know this has this class. So this class is matching in 5 elements. So all those matching elements will be pulled as a list of web elements, and it will return that list. So we can iterate over the list. So that is why iterator will be used. Iterator ITR equal to list dot iterator. So we are traversing over the array list using iterator, right? So we created an array list of strings. We added elements. Then we created another object of the iterator class for that list, for the specific list what we created, and then we are iterating over it, right? So it becomes so easy to work on. Got it? So any questions you have? See, without this iterator also we can do using a for loop, right? For see the same thing we can do int I equal to 0, I is less than the length of this list or size of this list, dot size I plus plus, right? Then keep printing. That's O. And then list dot get of, there is a method, get of index. So pass the index I. So this also will work, right? And this also will work. Both are available. But this is a traditional approach. This is a faster approach, right? You don't need to bother about it. The C iterator inside now does the same thing. Only difference would be, what is the difference? Here we have to explicitly calculate the size, provide the size, right? We provide some integer object, integer value I. Same thing iterator is doing inside, and it has been given to us. Okay, use it. So if you open this iterator class, right? So what it does, it traverses. So it also is an interface, right? See, it's an interface. So now the child classes which implement this this interface has to implement this, right? See, there is a class called for each remaining, means method, right? So but this has a body. So this is a abstract. This is an interface, but this is a method. What is saying, performs the given action for each remaining element until all elements have been processed, or the action throws an exception. The actions are performed in the order of iteration if that order is specified. Okay, so see, the concept of interface is we should not have any body, right? So what is iterator? Iterator is an interface, right? Public interface. And then it starts here. It has this has next, no body, e next, no body, right? And then remove has a body. So are you breaking the concept of interface here? You get confused, right? Are you breaking the concept of interface? Are you breaking the concept of interface? Question will come in your mind, right? So this is called the advancements they have done in Java. So what is that? The advancement is interface obviously has methods which do not have body, right? Right? See, now this also has next is implemented by child class. Next is implemented by child class. But this method remove is having some body, right? So it is opening and throwing new unsupported. So this is the advancements they have done to have a default behavior, right? So what they have done, they are saying in case there is some issue or some error from the user, then some default behavior I will show. Like I, as a parent, right? I will not implement the methods. Let the child classes only implement it, right? Who extend me. Now, but what happens if my son makes a mistake? Some default behavior should be there, right? So that's what the Java is doing. Is only in case of error conditions, do something, throw some error, right? Do something. So that's why they have implemented some of the methods just for the error handling conditions, right? So don't worry about it. So, but interface will never have body of the methods. Just that's the core rule. But they are improvising, right? Over the years, now they have a control over Java's code, right? So interface obviously all the methods should not have body. But now since they know if I provide body, what will happen, right? So they have provided only in case of rare scenarios to provide the default behavior of errors. When errors happens, what you should do, what the compiler will do. So for that cases, maybe some of the methods they are providing body, but only on error conditions, not the implementation. This is not the implementation they have done, right? So now we have seen array list. What's the next? There is linked list, right? So linked list we will see now. Linked list is what? From name only we will know. Linked list is linked, right? Linked to the previous or the next. So if you see in the diagram structure, linked list, say for example, I take this, right? 1, 2, 3, 4, right? So there will be singly linked list first. I'll tell you what it is. Just understand. So this whole is a list. So this whole is a linked list. Okay. Now linked list. So what will happen? This is the first element, right? The first element, say for example, has 1, 2, 3, right? And it will have null here. Why? Because in front of this, there is no element, right? But now when you come to the second element, 4, 5, 6 will have the address of the first, right? So this is at address, say 22. So it will contain 22 here, right? Now this address is 44. So this will first contain the value, some value, and then the address is 44, right? The last one also will have its own content, say 999, 9999. But then since the memory, this is the address, so this address is 78. So now memory address is stored here, right? 78. So this is singly linked list, right? So what you are doing, you are linked to the next element in in front of you. So you store the information, right? The first element has a different unique feature. The first element which is added to the linked list will have a null in the address. Why? Address part. Why? Because it does not have anything to store. Because it's the king. It has entered the room first. But whoever enters the room second should know its value and the element which entered before him. So it stores its value and it notes down the address of the first element, person who entered in the room first. So he knows 22, who is at 22 address, that I know. I have to keep track. So it tracks that. It keeps tracking of the previous element. Similarly, the third person enters the room now. Third person also has its own value, but it has to track the second person. Now he has to remember who entered second. So now what is the advantage of this? The advantage is traversing. Right now I have to retrieve all these elements. So I just have to hold of the first. Right? So once I have the hold of the first, then I will get a reference of the second, then the third, then the fourth. Or if I have the access to the last, is the best. See, last will have 78, it will go to here, 44, 44 will go to here, 22 will go to here, and will reach the first element. So this is how the memory is managed. So in the memory, they are scattered, but they hold the address of the linked element or the element who entered before them, right? Only one value, only one member you have to remember, not more than one, right? But doubly linked list, right? If doubly linked list is, you have to remember the previous and the next both. So what doubly linked list does? The same thing, just repeat it, but it will have two things. So doubly linked list will have the value, then address, two addresses it has a store. So why they have brought in doubly linked list? To make more efficient. Otherwise, in singly linked list, you have to hold the last element. If I hold the first element, then I don't know where to go because I don't have any address. So I have to find out the last element, then go to the previous, then go to the previous, then go to the previous to the first, right? So traversal is little time taking. You have to go to the find the last element first. So it will give me an address. That address I'll use to find out the previous one. Then the previous one will have another address that I'll use for the previous one of that. So similarly, you have to go and find out the first. But doubly linked list improves that. So this all know, it is not that they have implemented in one day, 1 month. Over the years, they started implementing all these things. Right. So now what happened? Same thing. 1, 2, 3 is value in the center, right? Now this stores the address of your previous, nothing is there. So null. But here it has this member, right? So it will store the memory 44. Right, the same address. See, 44 is here. I am using this. Now this second one also has some value, 456, but it stores the address of previous one, 22, and this, the second part stores the address of the next one, 78. So this is the 78. So if you see, the first element only is little king type. It does not need to store one of the list. It has a address of the next one, right, which entered the second. Similarly, this one, so this content will be 788, right? And then it has to store the previous one. What is the previous one? 44, right? And then this one, so this, suppose this address is 77, right? So store 77 here. So the concept is you have to have addresses of two, left and right, and your own value. So traversing is easy now. You don't need to find this last element. Any element you go, it will, you directly come to first, it will give you 44. You find the details of 44. If you come directly to this one, right, the third one, it will have two addresses, 44. So if address at 44 is this, so it will get the content. And then this will give me the content of this. So it is very, very dynamic, right? So now the last element is having 9999 and the address of this one 78, and the last also will not have anything because there is nothing, so it will have null, right? So the first and the last elements, who entered the room and the last who entered the room has to remember only one. Other people in between the first and the last, they have to remember two addresses, one for the previous one for the after whom. Before whom, suppose you stand in a queue, right? So when you stand in a queue, you should know where you are standing. You should see the first before you who is standing and after you also. Suppose you want to go to the restroom, then you will tell them both, I'm coming, okay, I will come in 5 minutes, I will stand again when I come back, right? So you need to remember the previous person also and your behind person also. You tell him in front of him, both the people, that I am coming, give me 5 minutes break, I'll come back. So that's what W linked list is doing. It is saying, okay, you store the address of your previous person also and your behind person also, so that you, when you come back, you will know where you have to stand again. So you will see their faces, then you will tell them, I have come back, I'll stand again. So they will allow you, right? If you don't tell them and go, if you don't remember their faces, then what will happen? Then you don't know where to see again, you have to stand in the last, right? So same real life implementation they have done is you remember the addresses of your previous person and your next person. So this is singly linked list, this is doubly linked list, right? So from a layman's point of view, from a very non-IT people also can understand, right? See how the programming world works. Very, very simple. But the implementation of these things, right, internally, there are lots and thousands of lines of code to implement linked list and doubly linked list internally. Like when I create, right? So when I create a linked list, let's go to the linked list class. So there must be a linked list, right? So linked list class, if I'm writing this line, right, what actually is happening, right? So what actually is happening internally, there are so many lines of code which get executed only when I write one single line of this code. Linked list string a1 equal to new linked list of string. So what it does, I cannot, I mean to say, obviously if I show you the class, right, it has this abstract methods and concrete methods both because it's a class, right? So it has constructor, right? It constructs an empty list first. There are multiple constructors. See, this another constructor, this is a parameterized constructor, then link first, link last. So all these methods are available. So they have to prepare these many things. See how many lines of code we have for one class, 1269 lines of code, and not this just one, right? All of these also internally will go somewhere else, right? Ordered. If I hyperlink and go inside another order, this also gets executed. So in total, right, in total, thousands of lines of code will get executed by just mentioning one line. This line, it is available for you. When you run this all will get executed, right? So linked list string a1 equal to new linked list, and then just the same way as array list, you are added a1 dot add Lakshmi, a1 dot add Sri, a1 dot add Avinash, a1 dot add Gangadhar, a1 dot add Pawan. I added them. So this linked list gets added. And see, now I don't need to worry about the address part. See, I showed you, right? This address part, 22, 44, 78, I don't need to bother. That Java will take care. Only I am worried about my values, right? Why should I worry about addresses? Addresses is job of JVM. Let Java only handle it. So I added see that there is no much difference. Array list, where is that? Array list, array list, array list, array list, right? So you just take this, Control C, come to linked list. right? And see the difference. Not much difference you will find. List, only the word linked is in front of this, right? And here there's a type is array list. What is the list? List is a type array list, right? So here also you can use array list also, right? This also is possible. So the difference is not much in syntax. Syntax looks very same, right? Only the names are different, but internally the structure, working structure is very much opposite, right? So array list completely works in a different way. There is no address collected, right? But linked list is storing the address also, right? And singly linked list and doubly linked list. So it works in two ways, singly and doubly, right? So now I've added same iterator. I am creating an object iterator of string type itr equal to the same al, right? You can give this as ll, not array list, ll, linked list. Al is for array list. I use that variable. So ll is for linked list. Link, L for link and L for list. So LL. So now I'm using the same iterator I created for array list and then I printed it. So what is this? This is now implemented in linked list. So what is the advantage? Advantage it is more efficient. Array list I created, but since it does not store any addresses, it will take some time to figure out all the elements in that array list. But linked list has an address stored in it, right? The previous and the next. If it is singly, it is storing the second person who entered second. Second person will store the third. Third will store the fourth, right? So traversal is faster. That is why they have implemented this. So linked list is another data structure which is widely used. But even linked list is there in Java. In automation world, you will still go ahead and use array list. Why? Because that's easy to use, right? So there is no need of iterator and all those things. So you will directly use, people go for ease of use, right? So people say, okay, typing line of code is less. Let me use array list. So generally array list it will use, but linked list you should prefer. See, these data structures are there available for us to use. We should try to use them. We can manage without them also, but we should use them. So these are the two data structures we will discuss today: array list and linked list. Remaining all tomorrow I will discuss. Got it right? So the whole tree structure collection framework is given to us for the user. Is a collection of interfaces and classes. Go and use it. So they have segregated them. How the memory is going to be managed. So based on that, you will be based on the type of application you are building. So you are building a Aadhaar or like credit card application. You set if you are building a queuing system, right? Ticketing system, right? So ticketing system, if you have to use queues, right? The IRCTC or any KSRTC, right? There is a queuing system, or like you have these token systems where first person has to come in and then only that person, like you have to book. Say, for example, you have to book movie tickets in Book My Show, right? So Book My Show, there will be 200 seats in a screen theater, right? If per screen. Now, when people start making booking, right? So that is a queue. The first person who books obviously will get the seat first, right? Second person will again get. If the seats are getting filled, then it will start showing. Okay, my queue is getting, my seats are all full. I don't have any. So the person who is seeing the full, he will not get tickets. So the first person who comes in, the second person who comes in will get priority. So they use queues. List is general, right? This efficient way of managing, right? List is an interface, and it has array list, like linked list, right? So those things are for managing the strings efficiently, right? They also have advantages, right? The singly linked list, doubly linked list. Singly uses one address, doubly uses both the addresses. So the efficiency you have. When will you use list? List should be used in general conditions, but when you are creating an application for ticketing, then use queues. If you're creating applications for very secured banks and Aadhaar or anything which requires unique identification, right? No duplicacy, then you should use set. So this is how the whole collection framework is provided for the user. So they all are scattered over Java, but it is inside the java.util package. And then you have to import that package and start using it. So similarly, we have vector and stack. Okay, so we have done, we'll talk about vector and stack, which are not used. Vector and stack is outdated, you can say. In very rare conditions, vector and stacks are used. Vector is almost like very old implementation, right? Vector, and stack also is last in first out, right? It is last in first out, LIFO it follows. So it is also used, but in rare condition. But in automation, we don't need that. You can use manage by array list and linked list. So array list implements the list interface, right? So we all saw that it implements the list interface. Okay, I think we are good. Any questions we have? The remaining of the collection framework we will discuss tomorrow. But these are the basics. The list and the array list are the widely used. We have maps also. Maps is out of this collection framework, but we'll have to talk about maps also. Hash map and hash table. So the hash maps are also used because maps is using a concept of key and value pair. Key and value. Like this doubly and singly linked list, they had the address of your previous and the next. Similarly, maps also use key and value pair. Key will be the address and value will be the content of that, right? First element. Similarly, you have to then, there is a hashing. In hash maps, there is a hashing concept where there is an algorithm to find out the calculate the value. How do I come to a key? So 1, 2, 3, if it is a key, how do is that 1, 2, 3 coming? There is a calculation, there's a hashing. So that hashing algorithm runs and finds out the key, and then you get to know I have to go to this 1, 2, 3 address and pick the value. So to find out that key, there is a hashing concept. So that also we'll discuss. Okay. Any questions, guys? Let me know. Just don't worry. Collection framework in Java is different classes and interface for us to use. Wisely take your decision based on your type of application, because developers are more interested in these things. For automation engineers, we have to validate, right? We have to do validations. We don't need to bother what queue I have to use, what array list I have to use to store, right? How to manage the memory and all. We don't need to bother. We have to just manage our validations. To use those validations, we have to see if I have to capture credit card numbers from a banking application, say the list of credit cards are there, then in that scenario, go and use set, right? If I have to manage normal strings, go and use array list, right? So don't need to bother about. In developers world, they have to follow these things strictly, stringently, right? So that's the way they should have. Their development skills should be good enough to utilize all the Java collections properly, efficiently. Otherwise, what will happen? They will have memory leakages and they will have inefficiencies, their applications hanging when there are load. So if you don't use a collection framework properly, right, the developers, not for automation testers, the developers, what will happen is simply say, for example, a developer uses array list because he thinks array list is easy to use. I will use array list and implement everything. He will use it, but there will be a time like Twitter and Facebook and all these things. There is billions of requests coming, right? So they will not be able to handle. Array list has also a limitation, right? So it will not be able to handle so many strings. So in that scenario, it will crash. So that's why, to overcome all these things, there are efficient data structures available in collection framework, like sets, maps, right, and queues, so that you can use them efficiently for your application. So you have to take, the developers has to take wise decisions what data structures they have to use, right? So this is for developers. For automation, we don't need to bother. We have to just manage with strings, array list, maps. That's enough, and sets. So those will be enough for us because we are doing only the validation part. Got it. Only rare scenarios, like for example, one automation tester has one application which where you can say there is a download, right? Excel file gets downloaded, right? And that file contains 1 billion records, right? More than like 10 lakhs, 20 lakh records in that file gets downloaded. In that scenario, now how do I validate the content of that big Excel file? Then that scenario will come to take wise decision. What we have to use, whether I have to use array list or in set or whatever data structure is available to us, right? So there will be very corner scenarios where all this automation tester needs to bother. Otherwise, it's of no use for us. We can manage with array list, maps, assets, hash tables. That also very rarely. Hash map and hash table also rarely. But if it is good, it is good if you use them. It is, I mean to say, faster, right? Efficient. But we can manage with array list and arrays. That's it. No, not in require, because most of the time we are just doing validations, right? So we have to just capture from UI, put all 5-6 strings in the array list, iterate over it using a for loop or an iterator, and then validate it. So we can manage. Okay, guys. Any questions you have, you can tell me if you are not understanding or if it's going over your head. But don't worry, slowly you will know, right? So everything will take time to grasp. So don't bother. But as always, I say, practice for half an hour. You got your recording sessions from Chetan?
No, sir.
No, sir.
I told him
It is on
yesterday.
the with syllabus copy also we haven't got.
Oh, I think I'll ask again. I have sent him some notes also, how about core Java, so that you can also practice the same programs. Okay. So those also I have shared. I'll ask him again today to share. Okay, guys, thank you so much. We'll meet again tomorrow and continue on the collection framework. Whatever is required from automation, we will use those and learn those. Extra things, we don't need them. We will put them aside. So many things are there in Java, not required at all, right? Only basic array list, strings, hash maps, and set. These are will be most widely used. Queues and all we don't use, right? And tree sets also we don't use. The singly linked list, doubly linked list we don't use. We don't need to manage, right? These are memory managements, right? Store the address of the previous, store the address of the next. So these are for developers to manage the memory efficiently. Otherwise, memory leakage will happen for them. So that's why they have to prefer wisely which one they have to use. So for us, we will be managing with array lists, maps, and sets. Okay. Okay, guys. Thank you so much. We'll meet tomorrow.
Okay, sir. Thank you. Bye.
Bye bye.
Thank you. Bye.
Thank you. Bye.